Hello. In this video, we're going to continue our study of graphs. And to start, let's just do a little warm-up. We have y equals x minus 2 squared plus 4. Let's go ahead and graph this parabola. So the vertex should be over at 2 and 4. So we've got 2 and 4 up here. And then we would go over 1, up 1, over 1, up 1. We're almost out of space here, so let's call that a day. Got enough points. There we go. A basic parabola. And this was easy to do because the parabola was in vertex form. We could clearly tell that the vertex was at 2 and 4. How about something like this, though? Here we have fx equal x squared minus 2x minus 15. Unfortunately, this graph is not in vertex form. And so it is a parabola because it's an x squared, but I'd encourage you to pause the video and put it in vertex form so that it's easier to graph. All right, assuming you gave that a try, we have to complete the square. So fx will be x squared minus 2x. We half it and square it. Half of negative 2 is negative 1, squared is plus 1. And then if we add 1, we have to also subtract 1. So this is x minus 1 squared minus 16. So the vertex should be at 1 and negative 16. Then we would go over 1, up 1, over 1, up 1, and we'd have something like this. All right, well, again, we were able to graph it because we took it, we turned it into vertex form. We grab that vertex, which is crucial for graphing the parabola, and away we go. But what I want to do now is something interesting. I want to take this parabola, and I want to translate it 20 units down and 19 units to the right, and then I want to discover the new x-intercepts. In other words, if you look here, there were some x-intercepts. We didn't solve them, but we could have if we wanted to. And now what I want to do is take this graph and move it down and to the right. It's going to be over here somewhere. It's going to have some new x-intercepts, and I want us to determine what they are. Go ahead and pause the video and give it a try. All right, to translate it, probably the easiest thing to do would be to move that vertex. So the vertex is currently at 1 and negative 16, and we would like to translate it down 20. So to do down 20, we should probably take that y value, and we should subtract 20 from it. To move it to the right 19, that's going to be the x values. And so we should go to the right, which means we'd want to add 19. So I think this is going to give us a new vertex of 20 and negative 36. So, I mean, that's not really even on the graph. That'd be, this is 20, way down here, who knows, is negative 36, something like that. And I mean, my graph's not to scale, so how am I going to be able to find the x-intercepts? Well, let's think about it from an algebra perspective. The function, if we know the vertex, we can write the parabola as x minus 20 squared minus 36. And the x-intercepts, if we remember, the x-intercepts mean y is equal to 0. So we can set y equal to 0. We can move the 36 over. We can square root. So remember, when we square root, we're going to get a plus or minus. So plus or minus 6 equals x minus 20. So x equals 20 plus or minus 6. So x equals 26 and 14. So those are our x-intercepts. Okay, we've been able to do this, but I mean, personally, it's a little bit unsatisfying. I would like to see the graph. I'd like to see these x-intercepts. It feels like maybe what we did was a little sketchy. And anyways, I'd just like to visualize what's going on here. So let's go ahead and type this into Desmos. All right, so we have f of x equals, our original function is x squared minus 2x minus 15. So we can see down here our vertex at 1 and negative 16. Our original x-intercepts, just for fun, were 5 and negative 3. And now I need to somehow take this vertex and move it. But clicking on it doesn't really let me move it. And I mean, I guess I could plug in the new equation. I could plug in, you know, we had y equals x minus 20 squared minus 36. So here we can see our new parabola with the vertex down at 20 and negative 36. And we have our intercepts at positive 14 and 26. But to be totally honest, I'm not satisfied with just typing it in because that's just sort of checking our answer. I would like Desmos to do the moving for me. I'd like Desmos to take the graph and I want it to actually move it to the right and move it down. I wanted to do the translations. And how would we tell the computer how to do that? That's sort of our question. We know what the answer is, but how do we communicate that to Desmos? Well, let me show you something here. What if I type in y equals f of x? But instead of having just the initial function, we know that we subtracted 20 from the y values. So let's put it in minus 20. Actually, what we can even do is put in minus a letter. Let's do k. And we're going to have k go to 20. So we can have it go to minus 20. We're going minus k. Okay, so we can see here that as k gets bigger, the graph is moving down. And now it's moved down 20. So we have that vertex with a y value of negative 30. Okay, well, let's move it to the right. Well, we know that when we're doing things inside the x, it's always opposite. So it's going to be minus 19. In other words, let's do minus and let's put an h in here. And we want h to be 19 because we're going to move it 19 to the right. So now we can use this slider here and we can take the graph and move it 19 to the right. There's our graph at 20 and negative 36. And here we have our two new x-intercepts. I can even animate both of these, which looks pretty cool. We can have them go both at the same time, and we can move it to the right and down. So there's our new graph. And by typing it in like this, I'll remove here the sliders and just put the final transformation. By typing it in like this, f of bracket x minus 19 bracket minus 20, I've been able to communicate the English of moving it right and moving it down into a language that the computer can understand. And this is what we're going to study here. We're going to study this idea of taking transformations like right and down and writing them in a form that the computer can understand so that the computer can do the transformations. And ultimately, it's not just a language the computer understands, it's also the language of math. This is how you write down the idea of moving the graph right and moving the graph down. You write it as an f bracket x minus 19 bracket minus 20. All right, so let's take a look at something. Here we have a very cool graph. It looks kind of like a W. If you're wondering what the equation is, it's the absolute value of the absolute value of x minus 1. It's not super relevant, so I'm just going to go ahead and blur that out for us because it might be a bit stressful for some of you. The main thing is that we have a graph in front of us. And what we want to do is graph the new graph, y equals f of x minus 5 plus 8. Now, I've written this in a form that the computer understands, but I want to make sure just before we get started that we as humans understand this. The x minus 5 here means we want to translate 5 units to the right, and the plus 8 means we want to translate 8 units up. So what I'm saying is, do some transformations. Take the graph, move it right 5, move it up 8. Okay, well, in English, I don't think that's terribly difficult to do. We can take some key points on the graph, maybe these 5 points here. We could put them in a little table. So we've got x and fx, -2, -1, 0, 1, and 2. And then we'd have 1, 0, 1, 0, 1. And now we're going to transform these points into some new points. And we're going to take the x values and we're going to move them right 5. You can imagine this point right here. 1, 2, 3, 4, 5. It's going to be at +3. And we can imagine moving it up 8. 1, 2, 3. Well, it's off the page now, but 4, 5, 6, 7, 8. All the way up top. Instead of being at 1 for a y value, it's going to be at 8. So what we're doing here is the x values, we're adding 5. And for the y values, we're adding 8. So go ahead and pause the video and see if you can fill in the rest of the table. Okay, this should be 4, 5, 6, and 7. This should be, oh, sorry, this won't be 8. My mistake. This should be 9. For adding 8. 1 plus 8 will be 9, sorry. 9, 8, 9, 8, 9. There we go. Now we can go ahead and take that table that we've created and we can draw the new graph. Let's just move down here. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 8, here's 9. 3, 4, 5, 6, 7. So we have 3 and 9, 4 and 8, 5 and 9, 6 and 8, 7 and 9. And then the original graph looks like it extends, so we'll add some arrows. And there's our graph that we have created based on the transformation. This is y equals f, x minus 5 plus 8. Okay, let's try another example. Let's see if given this initial graph, we can come up with a new graph. Fx equals x plus 4 minus 7. So your two transformations here are you need to move the graph 4 left and 7 down. Again, this means 4 units left, right? We always do the opposite for the x values, just like with parabola vertex. So if it's plus 4, we actually have to move it left or subtract 4. And here we have to move it 7 units down. So the way we do 4 to the left is we do subtract 4 from the x values. The way we move 7 down is we subtract 7 from the y values. So take the initial graph, make a table, make a new table, do these transformations, and see what you come up with. All right, so let's go ahead and see what we get. When I did it, my new table has the values -6, -5, -4, -3, -2, and -6, -7, -6, -7, -6. So on our graph, 1, 2, 3, 4, 5, 6, -6, 1, 2, 3, 4, 5, 6, 7, -7, -6. Okay, so we'll have something like this. Point there, 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 and there, roughly. And we get that nice W shape. Now, we're also going to check this on Desmos just to make sure it's the same thing. So I'll type it in and show you how we can compare our graph to the Desmos graph. All right, so here we see the original graph on Desmos, and we see the new graph in blue. You can see a few of those points highlighted there, -5 and 7, -4 and 6, -3 and 7. So yep, those are definitely the points that I came up with. And you can see the graph that used to be in red has been moved to the left and has been moved down. And again, we can just simply type in this equation to Desmos, and Desmos does the rest. We don't have to tell it in words, oh, move it left, move it down. We can tell it in symbols. This is the transformation equation, and it understands, and it creates a nice, beautiful new graph for us. So let's do this one more time. Here we have quite an interesting looking graph. It's sort of like a parabola, but the ends have been kind of folded down. And we would like to find f of x plus 9 minus 6. Notice that there's no arrows on the end. The graph just ends at those points. And so definitely be good to make a table of these original points for x and fx. And then we'll need to transform them, so we'll have to move them 9 to the left. In other words, subtract 9 from them and 6 down. So subtract 6 from them on the y values. But let's go ahead and take a look here. So we have a point -3, -2, -1, 0, 1, 2, 3. So at -3, the y value is -5. Then 0, -3, -4, -3, 0, and -5. So a lot of information there on the original graph. If we put it in a table, though, it kind of helps. And here we can transform it, where for the x, we're going to subtract 9. And for the y values, we're going to subtract 6. So go ahead and pause the video and come up with a new table here. All right, assuming you give this a try, this should become -12, -11, -10, -9, -8, -7, -6. And this should become -11, -6, -9, -10, -9, -6, -11. And then finally, we need to take those points and plot them on a graph. So again, I'll encourage you to pause the video and give it a try. All right, we should have something like this. So again, this is going to be down in the bottom left quadrant mostly. It might be a little hard to get to scale, but we'll give it our best shot. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's -12. And we know the graph is between -12 and 1, 2, 3, 4, 5, 6. And it goes down to -11. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So -11, -10, and -9, those were important points. So let's start here. We have -12 and -11. Then we go up to -6, down to -9, and then -10. Back up to -9, back up to -6, back down to -11. Again, it would be a little easier if we had some grid paper here, but we got the gist of it. Something like that. All right, so let's take some notes on this. These are some of our first transformations, and we are looking here at what are called translations. Translations. They're a type of transformation. And they're one of the easiest because you simply add or subtract. The general equation here for a translation is y equals f, x minus h plus k. And the h represents h units right. And the k represents k units up. So we're going to translate the graph either right and up, or if the inside ends up being a plus sign, then it ends up being left. And if the outside's a negative sign, then it's down. So as an example here, I'm going to make a little graph for you, just something nice and simple. We're going to have a little check mark. So this has the point -1, 1, 0, 0, and 2, just a nice little check mark. And let's do the transformation. I'll write it in blue. Y equals fx minus 2 minus 5. So go ahead and pause the video and graph that transformation. All right, assuming you gave it a try, we can go ahead and take each point. I'll put it in a table here just because it's a little easier. -1, 1, 0, 0, 2, 2. Now our new table, we have to add 2 to the x values, and we have to subtract 5 from the y values. So this becomes 1, 2, and 4. This becomes -4, -5, -3. So on our graph, 1, 2, 3, 4, 1, 2, 3, 4, 5. So 1 and -4, 2 and -5, 4 and -3. There's our graph, and we can see it's clearly been moved to the right and down. For some practice, you can try worksheet 6 and 6.5. And any things to remember, probably the most important thing is when you have f of x plus 2, this actually means you subtract 2. It means 2 to the left. Just like when you have the vertex, in vertex form, whatever number's inside the x, you have to flip the sign. All right, hopefully you enjoyed this video, and as always, thanks for watching.